Good evening. It is January 19th, 2026. As the final hours of this year fade away, the scientific community isn't just looking ahead to the new year, but reflecting on what may be the most profound yet quietly dramatic event of our lifetimes. We're calling it the cosmic date, the guest of honor, an interstellar object designated 3I Atlas. Tonight, we will deconstruct this event. We will peel back the layers of orbital data, trajectory analysis, and the eerie silence that surrounded this visitor. Because 3I Atlas isn't just another rock, it is a messenger, the third of its kind in recorded history to enter our solar system from the distant depths of the galaxy. If you appreciate in-depth explorations into the science reshaping our view of the universe, make sure to subscribe to the channel right now. We track the anomalies others overlook, and you won't want to miss the analyses planned for 2026. Let's examine the data more closely. The timeline here is unsettling. This object didn't just show up recently, it has been drifting through the outer reaches of our system for thousands of years. 3I Atlas has been a silent ghost moving among the sun-bound bodies. 8 millennia of near invisibility. It was only detected on July 1st, 2025. Consider that. We take pride in our sky surveillance and planetary defense networks, yet this object, traveling at a velocity that escapes the sun's gravitational grip, slipped past our detection until it was nearly upon us. When we plot the trajectory on the screen, look at this red line slicing across the planetary plane. The anomaly is obvious right away. Most comets and asteroids we track follow elliptical orbits. They are bound to the sun, swinging around it predictably. 3I Atlas is different. Its path is hyperbolic, an open curve. It arrived from the void and is heading back into it. The velocity is the key evidence. It moves far too fast to be a local object. It isn't one of ours. This challenges our earlier assumptions about the density of interstellar objects passing through. We had Oumuamua, we had Borisov, and now 3I Atlas. 3 visitors in less than a decade. The frequency appears to be rising. Or perhaps our detection capabilities are finally improving. In late October, the object reached its perihelion, its closest approach to the Sun. It passed at a distance of 203 million kilometers. To put that in context, that's roughly 1.36 times the Earth-Sun distance. In cosmic terms, that's quite close. It brushed past us, and we directed every available sensor toward it. We searched for a tail. We searched for outgassing. We looked for the signature of a comet interacting with solar wind, but the data remains somewhat ambiguous. And here's the critical point: the silence. 3I Atlas didn't brighten dramatically like a typical icy body should. It stayed relatively dim and compact. This behavior prompts the uncomfortable question: is it simply a rock or something more? The arrival of 3I Atlas shifts our baseline assumptions. If this is just a natural object, a random fragment ejected from a distant star system light-years away, the implications are staggering in one direction. But if not, if the lack of typical cometary activity hints at a more rigid, perhaps artificial structure, then we're facing a paradigm shift that would dwarf the Copernican revolution. We stand at a crossroads of interpretation. On one side, the natural hypothesis. This is an ordinary, perhaps extinct comet, maybe with a crust preventing sublimation. If we accept that, we must follow the math. And that math leads to a conclusion that's hard to fully grasp. So let's run the numbers. We take this single detection, one object in a certain volume of space over a certain time frame, and extrapolate across the solar system. When we do, the apparent emptiness of space begins to feel remarkably populated. As we move toward the statistical analysis in the coming segment, hold this image in your mind: a dark, silent shape tumbling through the vacuum, indifferent to the sun, indifferent to us, on a path set millions of years ago. It passed by. We observed it, but did we truly comprehend it? The story of Three-Eye Atlas isn't just about one visitor, it's about the vast ocean it traverses. And that ocean, as we'll see, is filled with unseen travelers. As we established earlier, the arrival of Three-Eye Atlas compels us to face a statistical reality that's difficult to wrap our heads around. We're examining one object, yes, but in astrophysics, a single detection often implies a much larger population. You don't stumble upon the only needle in the haystack by chance. If you find one, the haystack is likely full of them. Let's assume for this analysis that Three-Eye Atlas is natural. Let's assume it's an ordinary comet, as some astronomers maintain. If that's correct, its presence suggests an astonishing fact. We inhabit an ocean of interstellar drifters. Simulations based on the detection rate of Three-Eye Atlas combined with data from Oumuamua and Borisov produce striking results. Look at this density map on the screen. The calculations indicate that within our solar system, extending to the outer Oort cloud, there could be 1 trillion such objects present at any given time. 1 trillion, 10 to the 12th power. That's not an exaggeration. Right now, as you watch this, likely 1 trillion interstellar visitors are drifting through the dark fringes of our backyard. They are everywhere, but we miss them because they're dark, cold, and small. We only notice them when they approach the sun closely enough to reflect light or release gas. Three-Eye Atlas was simply the one caught in our spotlight. Now let's expand the scale. If our average star system hosts 1 trillion of these guests, what does that imply for the entire Milky Way? Here's the detail that strains existing models. Extrapolating that density across the galactic volume yields an almost unbelievable figure, on the order of 10 to the 23rd power interstellar comets. That's a 1 followed by 23 zeros, comparable to the number of stars in the observable universe, but all in the form of wandering rocks and ice within our single galaxy. This challenges our understanding of star system formation efficiency. To produce so many wanderers, every star system must eject material at an immense rate. Over the galaxy's 10 billion years, it would require processing mass equivalent to millions of suns to maintain this stream. Consider the mass transfer, a galactic conveyor belt, ripping material from planetary systems, hurling it into the void, where it drifts until encountering another system. So what does this mean for Earth? It means we've been brushed by these visitors for billions of years. Over our planet's lifetime, such close approaches may have numbered in the billions, 1 billion cosmic encounters we overlooked because we weren't watching or weren't here yet. We sit on our pale blue dot, believing we're isolated when we're actually in the middle of a cosmic rush hour, blindfolded. I want to pause and ask you, does realizing there could be 1 trillion interstellar objects in our solar system right now make you feel more connected to the galaxy or more vulnerable? Drop your thoughts in the comments. I read them all, and I'm eager to hear your perspective on this cosmic traffic idea. But there's always a caveat in science. All these figures, the trillions of objects, the millions of solar masses, hinge on one key assumption: that Three-Eye Atlas is a random traveler, its path shaped purely by chaotic gravitational forces. But what if it wasn't random? What if Three-Eye Atlas wasn't driftwood, but a vessel? This brings us to the alternative hypothesis, the one that unsettles many scientists, yet the data doesn't dismiss it. If the object is artificial, the entire statistical picture flips. We're not estimating trillions of rocks, we're considering a network. Building on this, let's revisit the flyby parameters: the velocity, the absence of a tail, the orientation. If Three-Eye Atlas arrived intentionally, random encounter math isn't the right approach. We should be evaluating intent, not density. What if its trajectory was shaped not just by gravity, but by design? Then the narrative shifts from swimming in debris to potentially being observed. Perhaps our stellar neighborhood was selected for a purpose. Perhaps we're not as solitary as we thought on this cosmic stage. As we transition to the technological hypothesis, we'll explore, if it's a machine, what might it be doing? And crucially, how do we differentiate a silent rock from a silent probe? The answer is emerging in a new branch of science born from Three-Eye Atlas. Given the statistical strain of the pure, random rock model, or the enormous mass it demands of the galaxy, we must consider the technological hypothesis seriously. Let's examine the motion data again. During its closest approach at 203 million kilometers from the Sun, 3I Atlas displayed subtle acceleration anomalies. In a natural comet, we'd attribute this to outgassing jets acting like natural thrusters, but as noted, no tail, no coma, no clear outgassing appeared. So if not gas, what caused it? The solar sail idea re-emerges, as it did with Oumuamua. If the object is extraordinarily thin, thinner than human manufacturing allows, it could be propelled by sunlight pressure alone. But nature rarely constructs vast, ultra-thin reflective sheets. Advanced civilizations might. If 3I Atlas is intentional rather than random, every prior assumption inverts. We aren't facing a galaxy crammed with 10 powers 23 rocks. We might be facing one laced with probes. Recall our own Grand Tour missions, Voyager, Pioneer. They fly by, collect data, depart. Now imagine a civilization billions of years ahead. They wouldn't send one probe. They'd dispatch swarms, millions of sensor nodes drifting between stars, activating near heat sources like our Sun. What if its path wasn't in different celestial mechanics, but engineered? This redefines first contact. We expected radio shouts or prime number sequences from distant stars, but perhaps contact arrives quietly, physically. In that scenario, objects nearing Earth become hard to ignore signals. Our location may be noted, or at least our star marked as interesting, perhaps for its water, stability, or life. Here's the key ambiguity. If 3I Atlas is a probe, it's likely unmanned, a drone following ancient algorithms. It may not even register us. It could simply log radiation, temperatures, orbits, storing data for a transmission we can't detect. But this creates a profound challenge, distinguishing rubble from artifacts. We can't rely on intuition. We need rigorous filters, because if trillions exist and only a fraction are artificial, we're hunting needles among needles. Scientists now advocate a fundamental shift, from passive skywatching to active interrogation. We need an interstellar candidate screening protocol. This leads to the engineering challenge of our era. We can't pursue every object, resources won't allow it. We need to identify from afar which dots moving at extreme speeds warrant attention. Proposals include infrastructure from Earth to lunar craters, a dragnet for potential technology. As we continue, we'll outline this interstellar net, how to spot a kilometer-scale visitor from an astronomical unit away. The answer involves lunar mirrors and ready interceptor fleets. Passive astronomy is giving way to active pursuit. Building on the possibility that artificial probes masquerade as comets, the community has moved beyond debate to engineering. To separate natural debris from meaningful candidates, researchers propose an interstellar screening system. This goes beyond bigger telescopes. It's a defense against ignorance, not just impacts. The first layer deploys wide-field surveys, sweeping the sky every few nights. We must detect high-velocity interlopers early, near Jupiter's orbit, unlike 3I Atlas, spotted outbound. Detection alone isn't enough. Resolution follows. Atmospheric distortion limits ground telescopes. Clarity demands space or vacuum. The bold proposal, a 100-meter optical interferometer on the Moon, mirrors arrayed in a crater, forming a virtual telescope stadium-sized. It could resolve kilometer-scale details from 1 AU away. With it, 3I Atlas would reveal pixels, craters or smooth metal, vents or antennas. This imaging filter distinguishes rocks from rockets. But if imagery shows anomalies, a perfect sphere, reflective disk, what then? The final layer, interceptor fleets, parked at Lagrange points, rapid response probes with high-thrust propulsion, nuclear or electric, to match interstellar speeds. The profile, rendezvous, sample, Analyze. A robotic arm scrapes surface material, checks composition in real time, ice and carbon or refined alloys. Science drives it, but defense lurks. If collision-bound and artificial, does it maneuver? Can we deflect? This is active SETI. After decades listening for radio, we're now inspecting delivered packages. What does this mean for the next decade? A pivot in priorities and funding, from static planetary targets to dynamic unknowns. The tech exists. Launches, robotics. Motivation was missing. 3i Atlas supplied it. The wake-up call. Each visitor gets ranked on a cosmic scale. Swipe left on rocks, right on anomalies. We're seeking matches. This ties to the classification framework, the Loeb scale, championed by the physicist advocating interstellar artifact searches. We'll detail its criteria for first contact and implications if we succeed. As we conclude, the infrastructure for hunting these objects is feasible in theory, but interpretation requires structure, a language for the unknown. The Loeb classification scale quantifies excitement and caution. Class C, standard interstellar comet, frozen volatiles, natural, swipe left. Class B, anomalies present, odd acceleration, rotation, reflectivity. 3i Atlas fits here, suspicious, not conclusive. Class A, unambiguous artificiality, geometry, transmission, maneuver. The hope is to witness an era beyond watching shadows, to meet the senders. Our history mirrors this. Voyager carries a golden record. In 1,000,000 years, it becomes an interstellar object elsewhere. If spotted, will aliens see debris or intent? We're seeking our reflection. The sender may be extinct, but their machines endure. Perhaps we meet not beings, but legacy. What does this mean for you now? The sky isn't vacant. Every glance upward might catch a galactic traveler. 3i Atlas's story is the prologue. We're building eyes and ships to greet them. If this deep dive into interstellar exploration resonated, please like. It helps reach more curious minds and sustains boundary-pushing content. Stay curious, keep watching the skies, and remember, we aren't alone. We're just arriving at the gathering. Atlas,